Hello, hello, welcome to 8.3, Prove It, a practice understanding task. Okay, believe we have the whole day for this one, because it is long. Alright, we're working with real shapes now. In this task, you need to use all the things you know about quadrilaterals, distance, and slopes to prove that shapes are parallelograms, rectangles, rhombi, or squares. Be systematic and be sure that you give all the evidence necessary to verify your claim. Alright. We have two pictures here. We have ABCD and EFGH. It's a little hard to read, not gonna lie to you. So luckily, you have this video and you can zoom in and see things. Is ABCD a parallelogram? Explain how you know. Well, what on earth is a parallelogram? You can kind of gauge from the name. A parallelogram has parallel sides. That is the only requirement, well, and four sides. It has four sides and they have two pairs of parallels. Okay, so that's really what we want to prove here. Now, never trust a picture. Just because this may look like a parallelogram, just because it may look like it has equal sides, does not mean it is the case, okay? We need a much more formal, systematic way of doing this. So, how would we prove we have parallel lines? Wait a minute. What did we just talk about with parallel lines? Oh yeah, they have the same slope. So if we can prove that these two guys have the same slope, and those two guys have the same slope, not the same distance as I have indicated here, but the same slope, then we good. Then we have proven what needed to be proved. Alright, so let's kind of copy paste this information down here. A is at -10, 12. B is at -4, 12. C is at -6, 8. And D is at -12, 8. Okay. Alright, so what slopes do we need to find? We don't need to find every single pair up here, right? Because we don't really care about AC or BD. We need to see, does AD parallel to BC? And is AB parallel to DC, or CD, however you prefer to write that. Because remember, slopes, same going backwards and forward. Let's get started. Slope formula, booyah. Let's do this. AD, right here we get 8 minus -10. I know you guys know slope formula by now, so I'm just going to power through one. Over 8, oops. Pardon me. No, that wasn't right at all. Apparently you know better than I do. Ha 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 ha. Okay, don't talk in math. We'll go up here. AD. 8 minus 12 over -12 minus -10. There we go. And we get -4 over -2 because that's -12 plus it would be 2, so -2. Yeah? Okay. Y minus y over x minus x. It's -4. Gotta make sure. I don't want to lead us down the rabbit hole. Yeah, okay. Over -2. See, I knew it. It would be +2. Yeah. Alright, so +2. And then we have BC, which would be 8 minus 12 over -6 minus -4. We get that same. I'm so going to run out of room here. Same -4 over -2. And we get +2. And so we get the same slope, and they are indeed parallel on one side. Check there. You guys check out the other one. Are those parallel? Remember, you can't be parallelogram unless both sets are parallel. So, go ahead and figure that one out. Okay, I hope you saw that those are both 0, right? Because they're pretty flat. You can count that. But if you did the slope formula, hopefully it came out to the same thing. And again, we get 0. So they are a parallelogram. Now, it would be virtually impossible to have the same slopes on both pairs, both sides, but then hit in a way that those would also not be equal distance. You could also check that. You could check. You would find that the distances were both 6 and 4.47-ish, but it's virtually impossible to have parallel lines on both sides and then end up meeting in different places that would cause different lengths. So we don't really need to check that one. We just need to make sure for a parallelogram they are in fact parallel sides. Okay, now I'm going to give you some time. Go ahead and prove, is EFGH a parallelogram? Again, never trust a picture. Trust your work. Go. Maximum, it's like 4 minutes, maybe 5. Okay, so so again, you should have paused the video, had some time to work on this, came up with a conclusion. I hope your conclusion was no. Let's take just one set. Is EF parallel to GH? Because it better be both. Let's try one. If it ends up being, we'll check the other one. EF is 5.2. I'm sorry. Yeah. E is 5.2. F is 15.0. G is 13, -9. And H is 2, -7. So E, F, G, H. Alright, slope between EF, giving up on my stylus, it's a little faster, would be 0 minus 2 over 15 minus 5, -2 over 10, which would reduce to -1/5. Remember, negatives matter. If one of them's negative, one is positive, it's still not parallel. GH would be -7 minus -9 over 2 minus 13. That'd be a +2 over -11. No combination of that is going to be a 1/5. And so we can already state, nah, brah, not going to work. All right, cool. So that we just proved was not a parallelogram. You may have done another set. You also would have found that those are not parallel, right? And so we get no for either way. Moving right along, number 2. Number 2 talks about rectangles. Rectangles are fancy parallelograms. So again, we have ABCD, and again we have EFGH. Parallelograms are rectangles are parallelograms, but not every parallelogram is a rectangle. You may have heard something similar about squares and rectangles. Think of it like levels. Anything is a quadrilateral, and a parallelogram is a quadrilateral that has parallel sides. A rectangle is a parallelogram that has 90-degree angles. So we also have to check 90-degree angles. We are not going to break out the protractor because that's just too much work, right? When the protractors are not always accurate. So we have to find another way to prove not only not only parallelogram, but rectangles. So how do we prove 90 degrees? Let's take a look at this. Let's just write down the points. -8, 3. Oops, sorry. Just want to get a bigger version, so make sure I get these points right. -8, 3. So A is -8, 13. See, I knew it. B, -2, 13. C, 2, 9. And D, -8, 9. All right, so first off, we got to prove parallelogram, right? We got to prove these things are parallel. Again, we're not going to trust a picture. We are going to find some slopes. Let's look at AB parallel to CD. We get 9 minus, no, pardon me. So 13 minus 13 over, doesn't really matter now, 2 minus -8. We get 0 divided by 10 which is 0. So 0 slope for one of them. The other one I can already see that's going to happen as well. -2 minus -8. We get, again, 0 over 10. And 0. Yay, they're at least a parallelogram on one side. We check the other one. You're going to find it's also 0 because... No, it's not. Just kidding. I think it's going to be undefined. But they are the same undefined. So here we will check that real fast. Now we need to check AD parallel to CD. I mean, they are vertical lines, so we can say they're parallel, but if we want to be super accurate about it, right? They could be like, one's super straight and one's like off by a degree, so we need to check. Whoops. Not CD, CB. Okay. CB would be, no, let's do AD because it's first. 13 minus 9 over -8 minus -8. Yep, and I can see some question mark there, right? But I get an undefined slope. Oh my goodness. 4? 4. So we'll call this undefined. Now, even though that's undefined, as long as the other one's also undefined, they match, right? And so as long as they match, they're good. I believe the other one is actually the exact same numbers. So we get 13 minus 9 over, yep, oh, pardon me, not exactly the same numbers, 2 minus 2. But again, we get 4 over 0, which is a big problem. All right, so far, check, it is a parallelogram. Now, how do we prove this 90-degree thing? How do we prove that they're all 90 degrees? Oh, right, something about 90 degrees and perpendiculars, perpendicular lines. So, first we check that they are parallel. Next, we need to check, is AD perpendicular to DC? Is this a 90-degree angle? That's the question. We kind of have to check them all. Feel like Pokemon, gotta catch them all, right? AB also has to be, no, let's do DA and AB. Let's do BA and BC and CD and BC. So I'm just doing every corner, just picking the lines for every corner. We're just going to check them off. We've already done the slope work. That's the best part of this. I didn't need to find more room because I already did the slope work. I just have to check, are they opposites and reciprocals? In this case, that's a little weird because it's undefined and 0, right? But those are opposites and reciprocals. So AD is right here. Here's AD. Undefined versus DC or CD. 0. Yep. Check. We can kind of make the same argument for the other ones. DA, AD, same thing. Undefined versus AB. Check. And then you'll see the other two also have checks. So yes, it is a rectangle. A lot of work to prove something is actually a rectangle, which is weird because this shape we've known since like 3rd grade is really hard to prove it actually is, right? Or even like kindergarten. I don't know about you, but I know my rectangle since kindergarten. But actually to be a rectangle required a lot. So we've got to check parallelogram, then we can upgrade to rectangles. Check out EFGH now. Is that one a rectangle? Pause the video and try it on your own. Alright, hope you had a chance to try it out. It is not a rectangle. It is a parallelogram. It's a beautiful parallelogram. But some of those are actually not 90 degrees. They're not perfectly 90 degrees. And so you end up getting that these are not rectangles. This is not a rectangle, pardon me. Not 90 degrees. Alright, cool. You can check the key for Y. Sweet. Moving right along. Last one. A rhombus. Okay, what is the definition of a rhombus? Well, a rhombus has all congruent sides. It's a parallelogram, and it has all congruent sides, but it doesn't have a 90-degree angle. It doesn't have a 90-degree angle. So it is a rhombus. Alright, so a rhombus has all congruent sides. Now you may just be thinking, well wait, isn't that just a parallelogram? Careful, parallelograms have the parallel sides, are the same size. A rhombus has all 4. So think of it like a square that doesn't have 90-degree angles. If you want to kind of think backwards. A square is a rhombus that has 90-degree angles. So it's like parallel to rectangle, or a rhombus to square. Okay. All right, cool. So we're looking at A, B, C, D here. It's over here in the corner, right? We need to prove that it has parallelogramness. That's the thing now. Is it a parallelogram? And then on top of that, we need to prove all the sides are the same size, the same distance. Hey, look at that, 8.1 coming back again. So distance formula on top of this guy. We're gonna need to save some room. Okay, first we need to see, is it a parallelogram? Which means, is AD parallel to BC, and is AD parallel to BC, and is AB parallel to CD? So, AB parallel BC, DC, and is AD parallel to BC? Okie dokie. Well, we've got 9, 8, and 3, 9. So 9, so A, we'll put it up here. We'll just circle it. 9 and 3, 9. So AB would be 8, 9, 8, and 9, 2. So AB would be 8 minus 2 over 9 minus 9. Again, we see that's a vertical line, and so it's undefined. Hopefully DC is as well. We get 9, so DC would be 9 minus 3 over 3 minus 3. And again, we get undefined. Visually, those ones are pretty nice, especially on a graph, but, you know, always double check it just in case. Cool, so that one matches. Check on that one. You guys check the other one. What do you see? Are they, in fact, parallel? Excuse me. That's probably weird on a video. Anyway, okay, so if you did check the other one, you should pause the video, check it out. You should have gotten negative 1/6 for both. So DA would have been, or AD, same thing, would have been 8 minus 9 over 9 minus 3, which would have been negative 1/6. You find the same thing for the other one. Get 2 minus 3 over 9, nope. Yeah, 9 minus 3, we get negative 1/6, bada bing, bada boom. Okay, so it's at least a parallelogram. Woohoo! If that wasn't true, then we know it's not a rhombus. But it's a parallelogram, which is good. Now we need to prove distance is all the same all the way around. That's not going to be fun. But we have to prove AD, AB, luckily it's the same calculation 4 times, BC, and not BD, CD. We don't need the middle ones, we just need going around. So, alright, I'll do one, let you guys handle the other. Okay, distance formula, A to D. Well, A, let's build those bones. We get 8 minus 9. 9 minus 3. Hey, that's similar to the slope formula I just did. Interesting. So it's negative 1 squared, which is 1, plus 6 squared, which is 36, square root of 37. Do I need to take that to a decimal? Not really, because I just want to compare it to the other ones. I get square root of 37. So let's look at the other ones now. AB, 8 minus 2, 9 minus 9. So 0 and 6, so square root of 36 would be a whole 6. I'm already done. I don't need to check the other ones. Why not? Because I get 36 in one of them and 37 in the other, and they need to be the same all the way around. They can't just be the same between two. Right? Just the same between two means parallel, or parallelogram. And so here, I'm actually proving it's not a rhombus. Not a rhombus. Close. 36 and 37 are dang close, let's be honest. But one of them is about 6.04, the other one's not. So unless it's the same distance all the way around, it's not a rhombus. You guys check out EFGH, and you will find, is it a rhombus or is it not a rhombus? All right, hopefully you found that it is not a rhombus. Is it a rhombus? Not sure. Okay. ABCD is not a rhombus because EF. Okay, my little answer key says ABCD, so I'm going to go ahead and just say, yeah. This is not a rhombus. If we look, that distance, not going to be the same as that distance. So, 1, 2, 3, 1, 2, 3, 4. And so it's not a rhombus either. No, not rhombus. If you disagree, you can discuss it as a class. All right, last shape, my friends. A square, the pickiest of all the shapes. Not only does it have to be a parallelogram, it has to be a rectangle, it has to be a rhombus, it has to be everything. It has to have everything. Every freaking thing. So first, let's start with the same one we were starting. Is it at least a parallelogram? Is it at least a parallelogram? Let's check that. So AB parallel to DC, and AB parallel to, no, I just did that one, D parallel to BC. Okay, are they the same? We could do this visually as well. We get 10 to 13, 3 to 9. I can't do it visually. It's fine. You can do it visually if you want to. I'm going to do it over here. So A to B, 7 to 14 would be 7, and that would be 4. So we get rise 4 over 7. Is it parallel to? I can do this. 13 minus 9. Wouldn't that be 6? Is that actually 13? I don't know if that's 13. I don't think that's 13. I think this is labeled wrong. I'm going to get a blown up picture. One sec. 10, 13. Nope. That's accurate. Oh, alright. Okay, sorry about that. 10 to 3 is 7, and 13 to 9 would be 4. Like he says it's not parallel, but sure, whatever. Okay, anyway, so this is definitely parallel. We get rise of 4 over run of 7. Check, parallel. Alright, cool, let's do it the other way. The other one now. Checking this guy. And this guy. Visual is not bad if you have the shape. It's just heads up, you may not always have the shape. So the other way we were doing it, kind of have to know that, right? Alright. So y to y. 13 to 6 would be 5. 10 to 14 would be 4. So we get rise of 5 over run of 4. Here we have 7 to 3, 9. So 7 to 3 would be 4. 2 to 9 would be 2 to 9 would be 7. Did I count wrong? I did. That was just me being stupid. Okay. That's a 7. Good job, Miss K. Okay, and then that's also 7. Okay, so this would be 7/4. And I believe that would be rise and out, so the slope is going down 7 over 4, down 4 and over 7, or negative 7/4 in both cases. Alright, cool. Ooh, that one was tricky. Check on both. They are at least a parallelogram, right? We have the same slope for both cases. Sweet. Next up, is it 90 degrees? We could check that. We have to check that. Let's check out if it's 90 degrees. So is it 90? Is it perpendicular lines between? So 90 degrees. Remember, we're not going to break out the protractor for that one. We need to check 90 degrees. Which one do we need to check 90 degrees for, though? CD, pardon me. Perpendicular to CB. We'll go DA perpendicular to CD. Wrap around A, DA perpendicular to AB. And then AB perpendicular to BC. Okay, so those are our 4 questions. Well, let's look at it. Here we have AB and BC. Yep, perpendicular, opposite reciprocals, check. So notice if you do the slope work for one, like you have the answer for the others. AD, or others known as DA, to CD, check. And then DA, to AB, check. And the last pair, check. So what I'm just checking is when I say CD and BC, I'm checking opposite reciprocals or negative reciprocals. Are they, in fact, negative reciprocals? And they are, so I put a check mark by 90 degrees. All right, cool. Last one, distance. It's not just a rhombus. We've decided it's a rhombus, right? Or I'm sorry, it's a rectangle. We've decided it's a rectangle, but now we need to also prove it's a rhombus on top of that, because to have all 3 means you are a square. So we need to check the distance of each of them. AD, that's a P. BC, CD, and AD. Go all the way around. Cool. Luckily, I can kind of tell most of these. So the distance from A to D is up here in the corner. No, it's not. It's here on the side. We have 7 to 4. You could do the whole x2 minus x1 and the y2 minus y1, but we already did that. That's what we did in counting the slope. So I know it's 7 and 4. 49 and 16, which would be... Just want to make sure I get it right. 65. Square root of 65. Can you already kind of tell something? You guys are my logical class. Can you kind of tell these are all the same numbers? But let's just double check. You never know. There might be a minus somewhere. BC was -7. +4. But that doesn't matter here, right? Because -7 squared is +49. And again, we have 65. Check out the other 2. CD is the top one, so +7, +4. We again get 65. And last but truly not least, the -7 and the +4. Yeah, you could argue it's a -4. Doesn't really matter though. 65. And check on all 4 distances. We can claim this is a square. Think of a square as the super pickiest shape in the world. But it is a square. All right. Quiz is coming up, I believe. Hold on before I say that. No, I'm sorry. That's the regular class. We do not have a quiz coming up. But we have a lot that we've talked about. We have piled on parallel, perpendicular, distance, everything we've talked about in proving these shapes. So hopefully this makes sense. Grab your homework. Get going.